Up till now, all of our examples have had a number that we've been putting in. But now we're going to look sort of back to the beginning of when we had to replace the machine. What would happen if you just put in an x? What equation would be, or what function would do both of those things at once? So in part A, we have f of g of x. So we can imagine you have your g machine and then your f machine after. You put something into g, whatever comes out goes into f. That's what f of g of x means. Now we're not putting in a number this time, we're just trying to find out what the equation would be. So if I just put in an x, what would come out of this one? Well, we look at our function of g of x, and everything that you put in gets multiplied by 2, right? And then you add 7. So if you put in a 3, you'd multiply it by 2 and add 7. If you put in an x, you multiply it by 2 and you add 7. So out would come 2x plus 7. Because that's what the g function does. Whatever you put in gets multiplied by 2 and you add 7. Now that 2x plus 7 goes into the f machine. And what does the f machine do? That function says whatever you put in gets squared, gets times by 2, and then you add 1. So if you put in 2x plus 7, 2x plus 7 would get squared, times by 2, and then plus 1. Now that's a picture showing the two machines and having one function after another. How would we write this if we had it to show our work in our notes? Well, we'd say I have f of g of x. If I work on the inside, if I put x into g, I would get 2x plus 7. Just the same thing we saw in our diagram. And then if that 2x plus 7 went into f, well, in the function f, anything that you put in gets squared, gets multiplied by 2, and then you add 1. So if you put in a 2x plus 7, well, that 2x plus 7 gets squared, gets multiplied by 2, and then you add 1. And so if we simplified this completely, what would we get? 2x plus 7 squared. Well, you'd have to multiply that out. That'll be 4x squared plus 28x plus 49. Multiply that by 2 and simplify. 8x squared plus 56x, 98 plus 1 plus 99. We'll worry about domain and range afterwards. Okay? So on this one, it asks about domain and range. We'll worry about that afterwards. But for right now, there's part A. Part B says you'll throw something into f of x first, and then g of x after that. So if I throw x into f of x, it gets squared times by 2 plus 1. That's what f of x is equal to. And then if I throw 2x squared plus 1 into g of x, everything in g of x gets doubled, and then you add 7. So I would take my 2x squared plus 1, I would double it and add 7. And if I simplify this, I get 4x squared plus 9. What's that? This is simplified as far as you could go. This one you wouldn't be able to factor because it's not a difference of squares. It's not equal to 2x plus 3 squared. Because 2x plus 3 times 2x plus 3, you'd get an extra 12x in the middle. And then part C, g of x, well, g of x is 2x plus 1, so I can replace that. And then the function g says whatever you have gets doubled and you add 7. So you would take 2x plus 7, you would double it and add 7, and simplifying this will give you 4x plus 21. So looking at your final equations, if we have to do the domain and range, which of those three look like they're the easiest to do domain and range? C? What kind of graph is C? Straight line. What's the domain of a line? Negative infinity to infinity, or everything, all real numbers. What's the range of a line? Also all real numbers. Perfect. That's the easiest one for domain and range. Of the ones that are left, which is the easiest one for domain and range? The second one. Why the second one? Domain of a parabola is everything. Okay, but that's true for the part A as well. What is the range of this one? Y is greater than or equal to 9. Because if you think of transformations, what's happened here? Your parabola has been stretched vertically and shifted up 9. Can you see that the vertex of this one would be at 0, 9? And so that one's easy because you could graph it from transformations to get a visual of that. The first one, again, it's a parabola. The domain is easy. But the range of our first one is hard because it's not in a form where we can do our transformations. So if you didn't have a calculator, you would have to complete the square. Remember that in grade 11? Try to find the vertex somehow. Okay? If you had your calculator, you could type this into your calculator. 8x squared plus 56x plus 99, and hit graph. When you have your graph, you need to find that minimum. So second, calculate number 3, your minimum. It looks like it's between -5 and -1. Yep. Push enter, and your minimum is at -3.5, 1. So your range, y is greater than or equal to -1. Was it positive 1? Yes, I think you're right. Yes, positive 1. Thank you. New smartboard glitch. Awesome. Questions for this one are 10 and 11.